Right, nice. So remember, we always look in Kelvin, and to convert from degrees to Kelvin, add 273. That's okay? Next, we need to remember two special temperatures. Anybody remember that? Two special temperatures. They are called fixed points. Right? And what's the exact name for them? One is upper fixed point, and the next is lower fixed point. Right? Upper fixed point is temperature of steam above pure boiling water. Lower fixed point is temperature of ice. Well, pure melting ice, right? Upper fixed point is 100 degrees Celsius. Lower fixed point is 0 degrees Celsius. Again, I gave you in degrees, you convert to Kelvin. Okay? Upper fixed point, 100 degrees Celsius. Lower fixed point, 0 degrees Celsius. Do my favor, convert to Kelvin one time, right? Get in the habit of converting Kelvin one time. In this case, wins. Okay, nice. How do we measure temperature again? What do we use? A thermometer, right? So we use a thermometer, and well, we have different types of thermometer here. You can always go back to the summary just to get up, right? We're not afraid that, you know. Yeah, sorry. Right. So you want to focus now on something called the kinetic theory of matter. Right? I'll give you a little summary on that. You could always, again, the notes are there. You could take your time and read the notes, but I like to go through some of these things with visualization, right? So first thing first, how do gases behave, right? And the way gases behave has to do with something called the kinetic theory of gases, right? What do we know with gases? They always what? If I have a gas particle in there, it wouldn't have many, but you have gas particles moving randomly. That's okay, Brianna? Right? They always moving randomly, right? And because of this random motion, so number one, they constantly move randomly, right? And because of moving randomly, what will happen? Right? So they collide with themselves, and what else? They collide with themselves and with the walls of the container as well, right? So they collide with themselves and the walls of the container. That's okay? Yeah. And because of these collisions give rise to what? Right. These collisions give rise to pressure. So therefore, collisions equal pressure. That's okay? So what would happen if you have more collisions? More collisions means that you end up with greater pressure. What would happen if you have low collisions? Low collisions will drop the pressure as well. That's okay? So if I increase the number of collisions in here, I am also increasing the pressure. So you remember this, right? Let's see who remember the three ways to. What are the three ways to increase pressure? Number one, right, make the space smaller. That makes sense? Make the space smaller. So let us decrease volume. Right? If it decrease the volume, means you have less space, more collisions, right? Even what else we can do? More collisions. Add more gas. Right? So add more gas particles. And thirdly, what else we can do? Increase temperature. Give them more energy, right? If I increase the temperature and give them more energy, they will be able to increase pressure, right? So we said increase temperature. And suppose Israel I wanted to do the reverse. Suppose I wanted to drop the pressure. What to do? Israel. Increase, decrease temperature, take out gas and increase volume. That's okay? Yeah. So now all of this here, temperature, volume, pressure, leads us into what we call gas laws. Right? We have laws now that govern how pressure, volume, and temperature behave. Okay? Go ahead, write it down. I want to explain the laws. Right? I want to explain the laws and then we'll do questions on this. Right? We have time, then we go to heating capacity and so on, right? So if you look back at what I made here right at the beginning of class, we did temperature, we just did kinetic theory, and now we're on gas laws. Okay? Imagine we could create your little chart for everything, right? Right? That's going to gas laws. Am I right, so the most important thing from kinetic theory, particles move randomly, they always collide. Because of the collisions, they give rise to pressure. How do I alter pressure? By altering volume, amount of particles, temperature. Right? Those are the three things that we can alter. Ready? Gas laws now. Gas laws gives us an idea how pressure, volume, and temperature, how they behave, right? And there are 4 laws, but there are 3 guys who did most of the work in it. One of the guys is Boyle's, right? Then we have something called Charles' law. Then we have pressure law. And last law is the general law. I'll start with the general law, because the general law shows how all 3 related. Here what the general law said. The general law says that if I have an initial pressure, multiply it by the initial volume, and divided by the initial temperature. 1 means the initial, right? Then that is equal to the pressure, right? The final pressure, the final volume divided by the final temperature, right? So the general gas law gives us this relationship. And we could use this now to work out any one of these. All right? Anybody remember what to do? How do we go from here to figure out the laws? What is it? Right. See what constant. Okay, so what you're saying. Let us say, let's do one actually, and then I will show you. Let's say I gave you a container, right? But the volume of the container is fixed. So the volume fixed. Right? Who didn't do this before again? Did not. You didn't do this before, right? Good. I got another question you, right? So let's say I heat this up, temperature 1. If I heat it up, will it have a pressure? Yes. So there'll be a pressure in here, P1. That's okay? Let's say now I increase the pressure to T2. What would happen to the pressure? Will it go up or down? Up. So therefore, P2 is more than P1, right? And then T2 was more than T1. Correct? Well, okay with that, David? So what that means is that pressure and temperature are directly related. Okay? If I increase pressure, temperature increases. If I drop the temperature, pressure will drop. That makes sense? Yeah? So from this, I can come with a formula. For those who remember how to do this, if I take off this proportional sign, I'll get an equal on K. So I'll get P on T is a constant. That is the formula that we're going to use for pressure law. Right? So here, V constant. I'm going to show you something. If V constant, and I can block it off here. It'll cancel off, right? And I will get P1 on T1 is P2 on T2. So pressure law is P1 on T1 is P2 on T2. So if I block off here and here, I'll get this on this is this on this. That's okay? Suppose I told you that pressure constant. Then the formula becomes what? Cancel off pressure here. You'll get V1 on T1 is V2 on T2. So you'll get V1 on T1 is V2 on T2. That's okay? And what the last part will look like. If I keep temperature constant, this will cancel, right? And I will get P1 V1 is P2 V2. Again, what's important is that you identify that temperature constant. So all these things could be explained using those two theories. Okay? Everything could be explained using those two theories. Like I showed you here. All right? And underneath these rules, write in red, temperature must be in Kelvin. Okay? Temperature must be in Kelvin. Copy down, I'm going to start with questions. So how do you know when to use gas laws? Right? And you'll know when to use gas laws based on the question asking you about pressure and volume and temperature. Okay? Still have more things in thermal, but it's the first part of it. So we'll try some questions, right? Ready? All right, so before we jump to questions, let me see what we'll learn and let me see what we'll pick up on it. For good bar in this code, whatever I get. All right, so I'm going to quiz a quick. Right, quick thing, log in quick. All right, let's go. La parte quanto due no? La parte tutte le cose. All right, let's go. Everybody ready? All right. Go ahead. It's about what we just did. Just got. Just. It's about 7 questions. How many go, Lord? All to get this wrong. Nice. Lagi mo lagi na. Nice. The video up there, boy. Alright, we're going on. Online survey, take over already. That's some of them close. Now, right there, we look for the share out. Next one. Ah, let's see the figure this. That's 100, yeah? We're gonna do formula with the front, right? Are you again? All right, now two element front here, the real well, you gotta answer real fast. Come on, sit down in front. Two element front leading here, you know. Come on, sit down in front. I will see, I saw a lap on here, but change it up here. It's so easy. Pressure load, true or false? Yeah, let's keep going. We're not going. Actually, coming up there, all the A's coming up here. All right. All right, you're holding one there, boy. Aha, let's see if I remember. I said this at the beginning of the class. No change for it again. Again, hit it again, hit it here. Yeah. I'll get you now. All right, nice. Okay, so let's apply some past papers now. Then hold on to the fine. As you got that. And I'll leave one to the right and separate them with the other. For example, Ashley Ford, Nathan West. 1, 2, 3, 4. Alright, let's go. Let me just try back this and see if we get paper from me. Oh, I lost it. Let's try one more, right? I like it, no? Although just had a squint a little. Right, you see that yet? No. Hold on, I'm gonna try it. Right, this is 2022, right? So the first part, we have to fill that table out. Right, I'll go in piece by piece. What type of thermometer will do that first? Minus 200 to 1500. Which one? D? Which one has the highest range? Beginning with T. Thermocouple. Thermocouple. Which one is 34 to 43? Clinical, right? That's one for us to measure our temperatures, right? And which one can measure the boiling point and freezing point? Laboratory, yeah. Mercury and glass thermometer or laboratory thermometer. Okay? And the range is what? 0 to 100. Okay? So for those who are doing this for the first time, and that's enough place, thermocouple here. Right? This one is the clinical thermometer. Right? Next one was the laboratory thermometer, or we could call it mercury in glass, right? Yeah, come on closer now. And the best I can do for now. That's the best I can do. Thermocouple clinical Mercury glass. Those are the treated thermometers. Ready? Let's go again. Next part. You can see that? Steady ice point in degrees and sorry, Celsius and Kelvin. Easy marks, right? Easy marks there. Probably 1 mark each. Huh? I can't remember. I'll take it. 2 was it? Right? So ice is how much? Right? So it's Celsius is 0 degrees Celsius. Kelvin is at 272, right? Nice. Let's go. Next part, they did a little graph. Everybody have that? Can't Voila. Yeah, 2022. Right? June 2022. Steady law associated with the graph, right? What you did? You all just did this in the Kahoot. You don't need the graph, just read the info. Peak pressure versus 1 on V. What graph is that? Which law is that? Boyle's law. It's still on the board, right? And that's what we did in the Kahoot. Right? So that's Boyle's law. Boyle's law. And what constant in Boyle's law again? Remember? What constant in Boyle's law? Temperature. Here's the graph. I'll have to keep turning back to the graph to help you out, right? But we need the graph now. Right? So look at the graph. You have a nice straight line. Your pressure values in kilopascal and your volume values in cm3. Okay. Right. Use the graph to determine the volume when the pressure is 250. How are you doing that? If I can zoom in there, it might help you. Here's what they said. They want the volume meter. Then you can pass it phone out there. Pass it up, pass it down. come up with phone boy. Right, look at it there. They want the volume when the pressure is 250, David. They want the volume, David. Be careful. No, write it down. Write it down in your books. Write down where you think the answer. If you can't see, take a picture and zoom in. Right, I'll zoom in a little more. I don't want to take off. Please look at the x-axis. Look at what you're reading off. The question asks for the pressure, for the volume when the pressure is 250. Okay? I will help you read out this. I'll help you with the reading, right? Here is 250. So come in here. Coming down there. How much is that? 0.01. 9. Okay. Right. The question is, what is the volume? What is the volume when the pressure is 250? Write your answer down. Do your thing. Right. So, right. This value here is the value for 1 on V, but it asks for V, right? That's okay. So therefore, we got to write this here. Right? 1 on V is equal to 0.019. So cross multiply, you'll get 0.019 V is 1, then solve for V. So that's 1 over 0.019. How much is that? 50? 52.6. So the answer is 52.6 cm3. That's okay? So it's important to read off the scales, right? Read off these values so you know what, right? You know what the axis is giving you. Okay? If the graph was P versus V, then go right ahead and just read the value off. Okay? Let's go again. Everybody okay with that online? You all okay with that? All right, are you okay with that? Yeah, all right, let's go again. And last part, use your answer in C part 2 to calculate the new volume when the pressure is 975. Let me see your handle up. Right, and that's zooming in here, right? All they want is the new volume. This is a P1 value, this is a P2 value. They want you to find P2, right? You're saying that. right? It does not apply here, but remember temperature must be in Kelvin. It does not apply here, but let's say, right? Or we do the next one. Right? What the law we using Ada? What's the law we using? Boy's law, right? So we're using P1, V1 is P2, V2. We can rearrange and we'll get V2 as P1, V1, column P2. Right? So that'll be 250. Right? We don't have to write like 10 to the 3 because it'll cancel off. Right? So, but it's a good habit to write the unit, right? So 250 will be 250 by 10 to the 3. V1 was how much again? 50. 56. 52.6. And P2 was what? P2 is 975 by 10 to the 3. Right? You don't have to write 10 to the 3 in this case, right? Right? Because they will cancel off. But it's a good habit to write it in case that they have different units, right? And what you got? 30. Right, question. Does that make sense? Pressure increased, but the volume went down. That make sense? Yeah. Because they are inversely related. Nice. Let's go again. Copy down. Any questions online? Copy down. Let's go again. Right. If you look back, you will see it's group, right? Right, let's start here. You can leave the definition. Write down 3 thermometers and their physical property. Or paper. Jan 2009, number 3. Jan 2009, number 3. See if we can fill out the table. Let me see who remember what the physical properties are talking about here. You can look in the handout, right? Right, so some of you all may have forgotten what I mean by physical property. Or all right. Calculate clearly. Ah, I cannot write. I get you. I get you. I'll load this back and I'll give nothing to people. I told you, you are listening, right? So the thermocouple, the physical property is what? EMF. EMF. Right? What's the next one? Mercury in glass thermometer. EMF is voltage. If you have voltage value, that is convert to temperature. Right? Yeah. First one is EMF. That's EMF of voltage. All right. What about the mercury in glass thermometer? What always changing? The expansionary liquid, right? So number two, mercury in glass, expansion of mercury. When you heat the mercury, it will expand. Or the alcohol. So the physical property is expansion of the mercury. What's the last one, Nathan? Can I get something by Nathan? Yeah? But clinical is use mercury and alcohol. Nah, not clinical. One more with a different physical property. Next week, take the handout and read it over. Last one is resistance thermometer. Resistance thermometer and the physical property is the resistance. Okay? Resistance thermometer. Right? Some of them use platinum. Platinum resistance thermometer. And the thing that is changed, the physical property is the resistance. Try this here, part C. Huh? I best I can do the physical property. A gas of volume 600 cm³ and initial pressure 2 by 10 to the 5 has its pressure reduced. If the temperature is constant, find the final volume. So you have to figure out which law to use. Read it back. A gas of volume 60 cm³, 60 cm³. So that's what? V1 or what? Right? So V1, I can't write, right? So I hope we only get the right values, right? And the initial pressure is what? 2 by 10 to the 5. That is your P1, right? So P1 is 60. P1 is 2 by 10 to the 5. It's reduced to 1.6 by 10 to the 5. 1.6 by 10 to the 5. If the temperature remains constant, what is the final volume? Right, take a little read, then tell me what law we're going to use. Take a little read, tell me what law you're going to use, right? Key thing is what constant. Just what constant is. Any question? Which one? Temperature. So which law is that? Boyle's law, right? He just said Boyle's law. Take your time working SI units. Yeah, you can look at see. Yeah, so it just makes sense to them. Right, so you recognize we have V1. Well, like give me a few minutes, I just write down what we have, right? P1. Before you work it out, the pressure drop. So would the volume go up or down? Up, because inversely related, right? Right, so most of us recognize we using Boyle's law, right? Give it what you will think of. What I would do is I would do a topic by topic, right? Now the send in the group so you can use it, right? Can't do that. I'll use it all years and very recent years thing before. So you'll have it and you can just work it. Right, so again, we saw P2. P2 is equal to P1, V1 all over P2. So that is 2 by 10 to the 5 multiplied by 60 all over 1.6. Now cancel, of course, how much you all got? Right? That makes sense. The volume went up. Volume went up, right? So that makes sense. Volume went up. No? But it makes sense. Huh? So you don't follow why I use Boyle's law? Right? And I use Boyle's law, I just plug in P1, V1, P2. And so that's all. Because it's a temperature constant, I use the formula and I make V2 the subject. So I get P1, V1, and P2. Right? I put P1, V1, and P2. That's all. Let's take the values and substitute. Right? Next one I'll make it look, right? Next one is second. Make sure you get ready. But you writing so? Plenty of these questions. Anyway, you'll realize base yourself just all right. So next week we review thermal quantities. So I wanted to review specific heat capacity latencies. Right? That's what you got to revise from coming. You'll tell me next week. You're in charge, right? And yeah, make sure next week you can tell me what's going on. All right, next one here. State Boyle's law, just write the formula fast. Oh, what year is it? Jan 2009. Jan 2009. Right? Just write the formula. Just write the formula and tell them temperature constant. Right? When you finish sketch graph of Boyle's law, we just did it in the experiment. 2 questions ago, or 1 question ago. 2 questions ago. Catch it quick. Just a line you have to show. Yeah. For the formula, we have to get it. The full temperature constant. Try that quick sketchy graph. Anything see that? Yeah. Correct them, you're in the phone now, let's check it. I said, no, you won't be on your phone. So, no, correct them, you're on your phone, I said, no, they will do that one. Okay. Right, so if you want to use back the exact one we did, pressure versus 1 on V is a straight line. Anybody have a different option? A different option is the one in blue. If you plug V instead, the graph will look like that. Okay? So you have the red option or the blue option. Okay? The red is the one we did 2 questions ago, and the blue is a different option, inversely related. Of course, you recognize how popular Boyle's law in questions are, right? You recognize them? Next one. Take it off. Go ahead. Read it. Do your thing. I'm going to underline this here. Question said to apply kinetic theory to explain. So when you say kinetic theory, are you doing calculations as well? As well? Are you doing calculations or you're using theory to explain? Theory, right? So use the theory to explain why there's an increased pressure. Right now, this is scenario explanation. Yeah, why is there increasing pressure? Take a little read. Right, a Kuliska had a fixed mass of air. Right, on the value, the air pressure is 210 above atmospheric. After a high speed chase, the air pressure is now 260 above atmospheric, right? Atmospheric is 100, right? For those who don't know. Right? Atmospheric pressure. Why did the pressure increase after a high speed chase? Claudio, right? Has to do with those things. After a high speed chase, why is the pressure went down? Remember we said some things will increase pressure, right? Why do you think the pressure went down? Right. Because throughout the high speed chase, the temperature inside the tire increased. Okay? Right? Because it have a fixed mass of gas, the volume not gonna change. Right? And what happened is that during the high speed chase, the temperature inside the tire, write it down, temperature inside the tire increased. Temperature inside the tire increased. Therefore, the particles will gain more energy. 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 And collide more frequently and collide more frequently with themselves and the walls of the container, with themselves and the walls of the container, with themselves and the walls of the container. Hence increasing the pressure in the tire. Okay, hence increasing the pressure in the tire. Okay, so greater temperature means more energy, more collisions, right? Greater pressure. Last part. Calculate the new temperature assuming no change in volume. Calculate the new temperature. Determine the new temperature of the air assuming no change in volume. I'm going back here. No change in volume means which law we using, David? No change in volume means which law we using? Volume constant. Volume constant. Pressure. You will see on that. Pressure law. Right? Right. So volume constant means you're using pressure law. Go back to your thing there. Last calculation. Look at it. Find the new temperature. Find the new temperature. All the info there. For those who blind, I am writing it here for you. T1, 24 degrees Celsius. T1, 210 kilopascals. And P2, 260. Please remember the question said above, right? So we have to add atmospheric pressure. Go ahead. Do your thing. Find for T2. Giving you 5 minutes. Sorry, 2 minutes. So that Rima has the answer. We are done. Okay. 3, 4. After you. All right. So the formula we're using, we all agree that P1, T1 is P2 and T2. Cross multiply and make T2 the subject, right? So you will get P1, T2 is equal to P2, T1. And I'm trying to make T2 the subject, right? So that's P2, T1 over P1. All right. Let's plug in our values. P2 is 360. And P1 is 310. Because this said above atmospheric, you have to add it, right? We have one side problem, Dante. We have one side problem with temperature. What to do? Come with the Kelvin. So that'll be 24 plus 273. Then you work it out. How much is that? How much is that? Take it time. One person has 344.9. That's on the top, right? 345 Kelvin. Pressure went up, right? Yeah, the temperature should go up. What my calculator? Which can everything right? Yeah, my calculator. Huh? 45. Anybody else get up? Yeah. 345 Kelvin, right? Right? You can convert to degrees if they ask you. How do you convert to degrees again? Minus 270. All right, now